Hello.
Hi, Miss.
So, previous session we did few theorems on circle. So it was symmetry properties of circles, and then we had two on this one, and then we did the tangent. See, focal points are equal, and then we did another theorem, angles relationship in a circle. That angle in a semicircle is 90-degree, then angle at the center is double of the angle on the circumference. Then we did um, hmm. So now we will do alternate segment theorem and theorems related to the cyclic quadrilateral in a circle. Okay, so let's see that.
Okay.
So, alternate segment theorem. Before we start it, you must know what is a segment. So, if you remember, yesterday we did when a circle, you have a circle and it is divided by a chord. Let's say it is divided into two parts, right? So, this smaller part, this is called as the minor segment, and the larger part is called as the major segment, right? So, this is your minor segment and this is your major segment. Is this clear to you?
Yes, Miss.
Okay. Now let's do few. Okay. Let's see what does it mean. The angle between a tangent and a chord drawn to the point of contact is equal to the angle in the alternate segment. See, it says that the angle between a tangent and a chord. So, when you have a circle and you have a chord, then if a tangent is passing like this and it is touching the circle at this point where chord is there, right? Okay, then an angle is formed between this chord and the tangent. Am I right?
Yeah.
Okay, now see, this chord is dividing the whole circle into equal parts. So see, this is one. No, no, no. This is one part. One second. Now, this is one minor part, and above you have the major segment, right? Now, what it says that the angle between a tangent and a chord drawn to the point of contact is equal to the angle in the alternate segment. Now, if this is one segment, then its alternate segment is here, right? Now,
Yeah.
from this chord, again, we have something like this. An angle is formed in alternate segment, right?
Yeah.
So this angle which is formed in the alternate segment will be equal to this angle. Is this clear to you?
Yes, Miss.
Okay. Now take this circle. See, in this circle, here you have a chord. See, this is the chord and this is the tangent. Here you have this chord. Wait. We have both the sides chord. Okay, now we will take this chord because angle is formed here. So this is the tangent and the chord here, and angle is formed. Now this is one segment and its alternate segment is here. So from this chord there is an angle formed in the alternate segment. Now this angle will be equal to this angle formed by the chord and tangent. Is this clear?
Yeah.
Okay, now in the same manner, now you have a chord here, and this chord and this tangent form an angle here, right? And from this chord, angle is formed in this segment, right? Now this angle will be equal to this angle. Is this clear to you?
Yes, Miss.
Okay, now let's see a few examples on this. Wow, this looks good. Huh. So you can see a so yeah, we have a circle here and you can see that there is a tangent like this, right? Yeah.
Yeah.
And now you can see that you have a chord like this. Now this chord is dividing the circle into two segments. One is this and one is this side. And from this chord itself, angle is formed here. Can you see that?
Yeah.
In
Oh
alternate
yeah.
segment, right? Yes. Now
Yeah.
you see that this chord and this tangent makes 55 degree, right? So if this chord and this tangent makes 55 degree here, then can you tell me what will be the measure of x?
Major of um. Is it the 55 one?
Yes, this is
Yeah.
55 because this is in alternate segment from the same chord. Okay,
Yeah.
so you can say x is equal to 55 degree, and you must write the reason angle in alternate segment. Is this clear to you?
Yes, miss.
Okay, now let's see another. Now, yeah, see, you have another chord here, right? So this chord and this tangent, see, this tangent, they are making a 45 degree angle. Is this clear to you? Here 45 degree angle is
Yes.
formed. Now you can see this, that the same chord is also forming an angle in this segment here. See, and that angle is nothing but w. Am I right? Yes.
Yeah.
है ना? So from this chord another angle is formed in the alternate segment, and this angle w will be equal to this angle here. Is this clear to you?
Yes, miss.
So we can say w is equal to 45 degree, and the reason is angle in alternate segment. Okay, now I want you to answer what is the value of v here. How can we find the angle V?
Um. So like angle of a triangle is 180 degrees. So we found W and X. So we add them and subtract them by 180.
Okay, so yeah, you can say this, as well as you can also say that this is a line and we have three angles on the line. So sum of the angles on a line is 180 degree, right? We can do that also. So this will be, so I must say that 55 degrees plus V plus 45 degree will give you 180 degree. And the reason is angle on a line, angles on a line sum up to 180 degree, right? So you will have this one as v is equal to 180 degrees minus 80 degree, sorry, 100 degrees now. 45 plus 55 is 100, right? Hence you get v is equal to 80 degrees. Is this clear?
Yeah. Yes.
Okay, now what is left? Now we need to find what is the value of y. So how can you find the value of y? Tell me.
For Y, isn't it gonna be the same as V?
V. And the reason?
Because like it's basically a mirror, like the cyclic quadrilateral.
So when we
Oh.
have cyclic quadrilateral, then
Oh yeah.
sum
It's
is,
100. It's 100. 100.
yeah. So when we have a cyclic quadrilateral, the sum is 180 degrees, right?
Yeah.
So you will say v plus y is equal to 180 degree. Even though I have to explain you that cyclic quadrilateral. Now v is 80 degree and y is, we have to find it out. So you will write y is equal to 180 minus 80, that is 100 degrees. Is this clear to you?
Yes.
Okay. Now, let's see the next question. Okay. Hmm. Wow. We have here two tangents. Can you see? We have a tangent here which is touching this chord, right? And then we have a tangent here which is touching this chord. Am I right?
Yeah.
Okay, now you see that when I have this tangent which is touched by this chord, so what happens here? One segment is formed, right? And the alternate segment is here, isn't it?
Yeah.
Okay. Also, you have like the angle is formed from this chord. See, from this chord and the tangent here, they are forming this angle, that is 63. So your segment is, we will consider this as one of the segments, and then your alternate segment will be here. For from this points we have this angle alpha. So what will be the measure of alpha?
60. Alpha is. Wait, first we find beta. Alpha is
No,
90. Eh, no, no,
no, no, no, no.
90.
No, we don't have a semicircle here. See,
Yeah.
this is a chord, okay, and then this chord and this tangent is forming 63, and this is your alternate segment where angle is formed. Now tell me what
Mm,
is the measure of this alpha?
63. So it's going to be.
Right.
Oh,
Yes, this is 63. Got it?
yeah.
Alpha is 63. Now listen carefully. Okay, so this is 63. Now you see that we have angle beta here. Okay, now you can see that beta is formed by this tangent and this chord, correct?
Yeah.
In this segment, and from the same chord we have angle alpha here. So what can you say? What will be the measure of beta?
Beta is also 63.
Very good. Beta has to be equal to alpha. Okay. So
Yeah.
alpha is equal to beta, which is equal to 63. Any doubt in alternate segment theorem?
No.
Hmm. Okay. Let's go to the next one. Now, now we have cyclic property. The last two properties relate to cyclic quadrilaterals. Okay, the opposite angles of a cyclic quadrilateral add up to 180 degree. Now you must know what is a cyclic quadrilateral. Any idea what is cyclic quadrilateral?
The quadrilateral, if you cut it to half, it's going to be the same.
No. See, you have a circle and inside the circle you have a quadrilateral. Means cyclic quadrilateral have all its vertices on the circle, right? A cyclic quadrilateral will have all its vertices on the circle. Is this clear to
Okay.
you?
Yeah.
When see all four vertices are on the circle, then only we call it as cyclic quadrilateral. Suppose I have a circle like this, okay, and I have a quadrilateral. Wait. And I draw a quadrilateral like this. What did you say? Is this cyclic?
Yeah.
Why? How?
Because it's inside the circle.
No, but a cyclic quadrilateral is a quadrilateral which have all its four vertices on the circle.
Oh, wait. So this is the one to my left, to the left is
This
not
one.
cyclic quadrilateral. The one to the right is
Yeah.
cyclic.
Why this is not a cyclic quadrilateral? Tell me.
Because the one of the side is like passing out of the circle, which is not a
Yes,
quadrilateral.
one of the vertices is not on the circle. That's why this is not a cyclic quadrilateral. So, this property of circles we are going to study is all about cyclic quadrilaterals. Means when and only when all the vertices of the quadrilateral falls on the circumference of the circle. Is this clear to you?
Yeah.
Okay, now what is this property of the quadrilateral? It says that the sum of the opposite angles is always 180 degree. So if A and C, angle A plus angle C is equal to 180 degree. Okay, angle B plus angle D is equal to 180 degree. Is this clear to you?
Yeah.
Okay. Now, suppose if I say this is uh, 70 degree, then what will be the measure of this angle?
Um, 70. That is also 70.
Read this. How did I explain you this
Oh,
relation?
wait, wait. Ah, 110, 110.
110, because the sum of the opposite angles is 180 degree. So when this is 70 degree, so this one will be 180 minus 70, that is 110. Okay, now suppose if I say this one is 120 degrees, what will be the measure of this?
60.
Yeah, so this one will be 180 degree minus 120, that is 60 degrees. So this is clear to you, right? Now let's
Yeah.
see one more property. Okay, so this is each exterior angle of a cyclic quadrilateral is equal to the interior angle opposite to it. Okay, now you see that here is a cyclic quadrilateral. See, A, B, C, D. All the vertices are on the circle, right? On the circumference of the circle. So this is a cyclic quadrilateral. Now what it says that each exterior angle of a cyclic quadrilateral. So you see, if you extend this line, then you will get one angle here, right? Yes.
Yeah.
Okay, one sec. Now, and if we extend this line also, you get one angle here. You extend this line also, you get an angle here. You extend this line, you get an angle here. Now, what are these angles? These angles are exterior angles of the cyclic quadrilateral. Am I right? Yeah.
Yes.
Okay, so what does this rule says? It says that each exterior angle of a cyclic quadrilateral is equal to the interior angle opposite to it. Now, this is exterior angle of this cyclic quadrilateral. Then this will be equal to interior angle opposite to it. So this A is interior angle opposite to exterior angle x. Is this clear to you?
Yes, miss.
Okay. Now I'll show you. Let's see one example on this. Okay. Now you see here. Here I say that this is 100 degrees and this one is 80 degrees, right?
Yeah.
Okay, by following the cyclic quadrilateral rule, that sum of the opposite angle is 180 degrees. So if this one is 100, so this is 80 degree. Now, can you tell me what will be the measure of this by following the linear pair rule? Sum of the angles on a linear pair. See, you can see there is a line here, right? And on the
Yeah.
line you have one angle as 80 degrees. So what will be the measure of other angle?
Uh, this is then the other one is 100.
Right. And you see now, see, this is exterior angle which is equal to the interior angle opposite to this.
Oh, yeah.
Right? Can you
Yeah.
relate it now?
Yeah.
Good. Okay.
So basically, the exterior angle is like same as the interior opposite angle.
Opposite angle.
Okay.
Yes. Okay.
Yeah.
So let's solve a few questions based on this. Okay. Now, here is a circle and here is a cyclic quadrilateral because all of its vertices are on the
Inside the circle.
On the circumference of the circle, inside the circle.
Oops.
If you say the word inside the circle, you can also have a quadrilateral like this, but
Oh,
this is not.
yeah.
This is inside the circle, though it is not a cyclic quadrilateral, so it
Okay.
has to be on the circumference of the circle. Okay,
Okay.
now this will be easy for you. Okay, so if this is 100, what will be the measure of A?
Eh, A is gonna be 80.
Okay, so because some of the opposite angles will be 180. So A plus 100 is equal to 180. Hence, A is equal to 80
80.
degrees. Right? Okay.
Yeah.
Now, what will be the measure of B?
B 65.
Very good. So you have B plus 115, which is equal to 180, and B is equal to 180 minus 115. That is 65 degrees. Understood?
Yeah.
Okay. Let's see a few more. Huh. Here you see. Okay, again we have a cyclic quadrilateral, all the vertices on the circle, right? Here this is 82 and this you need to find, and then this is 110. So now looking at this measure, can you tell this is equal to which one?
Uh,
Hmm.
110 is
Hmm.
equal to D. D.
D. So do you think D is opposite to 110?
Wait.
This is opposite or alternate? Decide.
Alternate. C.
Alternate. C. So
C.
yeah, so C is equal to 110. So this will be, so you can write the interior angle opposite to exterior angle of cyclic quadrilateral. Understood?
Yeah.
Okay, now so C will be 110. Moreover, if you are not able to apply this rule, you can always go for the angles on a linear pair. So if this is 110, then E is equal to 180 minus 110. That will give you 70. So if you have 70 here, then sum of the opposite angles of a cyclic quadrilateral is 180 degrees. So you can find C this way also. Understood? C can also be
Yeah.
done like this. Hmm? Both the ways we get the answer, but you must know both the rules. Yeah. Now, if this is 82 degree, what will be the measure of D? Now, this is easy for you, right? D equals,
Uh,
you tell, just tell the steps. I'm going to solve it for you.
this is, oh,
Hmm.
wait. So 71. That is 18.
What
Wait,
if
wait, wait. 98. 98. 98.
98?
98?
So
Yeah,
you have
98.
to tell 180 minus 82. That will give you 98 degrees.
98.
Okay. Yeah.
Yeah.
Good. Now let's work on this. So, okay, does this shape looks familiar to you? Can you make out what shape is this? Definitely, this is
Kite.
quadrilateral. Yes, this is quadrilateral and this is a cyclic quadrilateral. But because of this marking, we understand that this is a kite. Okay, hence this is a kite. Can you tell me what is the measure of I now? Hmm, I.
I is double this. No.
No double. 82, this is
No.
cyclic quadrilateral, right? Put the formula for
Yeah.
cyclic quadrilateral. What is the,
Oh,
hmm.
98.
Okay, so I plus 82 will give you 180 degrees, right? And then
Yeah.
I is equal to 180 minus 82, that is 98 degrees. Clear?
Yeah.
Hmm? Okay.
Yeah.
Now, there is a property of kite which is followed here. Can you tell me what is that property of kite?
90-degree thing.
No, there is no 90-degree thing. We don't have any diagonal and it is nowhere mentioned. Hmm.
Uh,
Hmm.
Wait, I remember.
Okay,
Wait.
so when you have a kite, okay, whenever we say that any shape is a kite, then there are two pairs of sides which are equal. So here this and this side is equal, this and this side is equal, but always there is one pair of angles which are equal. So J is equal to K, right? And
Yeah.
already we have done I plus this one is 180 degrees. Since this is a quadrilateral, so the sum will be 360 degree. So out of 360, 180 is here and another 180, so it will be half of 180, it will be 90. So this is 90 and this is 90. Is this clear?
Yeah.
Okay. Okay. Okay, we have one more question. Very good. Okay. So let's go through this question now. Okay, so you can see that, okay, we have a tangent like this, and then we have a cyclic quadrilateral here, and then you have a 60-degree here. Okay, and then the marking says that this and this marking says that this is an isosceles triangle. So what can you say about rest of the things? Okay, let me explain you. Since this is 60-degree and this is this, because of this marking, we understand that this is an isosceles triangle. Okay, so if this is 60-degree, then this is also 60-degree, right?
Yeah.
And if two are 60-degree, obviously this is going to be 60-degree. Yes.
Oh yeah.
Okay, and now if you follow the linear pair theorem, the sum of the angles on a line is 180-degree. So this is 60, then S will be 180 minus 60, that is 120.
120.
Okay, and now this
You
is
also 120.
one moment, Vita. Yeah, so this is also 120, and
Then
S.
R&D is 60 60.
Yeah, very good. Because the sum of opposite angles of a cyclic quadrilateral
180.
is
Yeah.
180. And we are done. That's it. Okay,
Yeah.
so this
Oh,
completes your circle theorem. If you have any doubt or any past paper question, you can put in the comment section. Okay, and see you in the
okay.
next class. Bye bye.